So today I'm going to design a standalone system on PV syst. So let's start by clicking on standalone. Now first I will start a new project and name it Lahore. Now for the designing PV syst, first we require to define a site. To define a site, to go to new site, and you can select a site by giving just coordinates here, just longitude and latitude. Write the longitude and latitude of the site here, and you will get the medium data. Or you can just go to this interactive map and select your site. So I'm going to find Lahore first. Just go to Pakistan, or you can search, just write the location and search. So I'm in Pakistan. Now let's search railway station Lahore. Now search it. So now we have a pinpoint of railway station Lahore. So here is the Lahore junction. Accept the selected point, and now I'm going to give a site name. Let's write it Lahore. Now I'm going to import data for Meteor 8.1. You can select whatever you want. It will take a second. So now I have the data of Meteor. Now I'm going to change units to watt per meter square here. Now click OK. You have to save that site. So let's save it. Click OK again. Now just save the early analysis. Okay. Now you have saved the selected site. Now we are required to save the project for the further. So let's save it. Now we have the enable the option of orientation user need. So let's define the user orientation of our PV panels. You can select whatever you want. I am going to select 35 degrees Celsius plane tilt and azimuth angle to be 0, and orientation optimization with respect to the yearly radiation yield. Now I have selected the 35-degree and azimuth angle is same. Select OK. So now static shows that we have to save the file. So let's save it. You have to save the file after every step. Now we have enabled us define the user need. So let's define it. So I have a one air conditioner. So let's write here one. Now I have one air conditioner. So I'm going to use define air conditioner hours and wattage here. If you have more than one air conditioner, you can change the number to 1 to 2, or you can add other LEDs or other systems. Now we have to define hours. So for that we are going to go to tab hourly distribution. So you can just click left click in which hours you want to use that air conditioner. I'm going to select 11, or if you want to deselect that, just right click on the squares. It will be deselected, or to select again just left click it. So I've selected the, let's say, 10 hour tenure of the air conditioner. So go to previous. Yes, you can see that I have selected a 10-hour duration of our AC. I'm going to, for the yearly simulation, I have almost you can say 40,024 watt hour per day. This is my user need. So let's click on OK and save this file again. Now I have to design a system, a PV system for my user needs. So let's design it. Go to system. So here first you can see the upper column. Here we can see required autonomy. This is the backup power. You can change it to whatever days you want a backup power for. For example, I'm selecting a 1 day backup, and here the battery voltage which you are going to use, or you can just select a battery and it will be automatically updated. Now I'm the suggested PV power is required 18,000 watt nominal. Now I'm going to select a battery. Let's go to, this is the showing the LG SEM manufactured batteries. Now you can change it to all technologies, or you if you want any specific technology battery, you can select it from this drop down menu. And now I'm going to select a voltage of, let's say, 12 volt. So now you can see the number of modules or the battery power, battery voltage are updated up here. And let's say we can the change the battery. uh, there are many batteries, you can choose whatever you want. 2 volt battery, 12 volt, 46, 26 and 51. Let's choose 51. You can see this, the voltage, battery voltage is updated here, and the number of modules are 6. So we have also keep in mind the battery capacity. So here it is, almost we need 920 Ah, and down here we have selected the battery, and the global capacity of that battery is 936 Ah, which is enough for us. It is will be automatically selected based on the number of modules and the battery. So if you have selected a battery which have lowest Ah value, then the number of module will be increased. So I am going to select. So now I'm going to select a battery. Here you can say for 48 volt. I need 16 modules. Just let's decrease that number of modules. So on the basis of AH, I'm going to decrease that number of modules. Now I need only 8 modules. By the number of modules can also be increased or decreased, or the suggested PV power can also be decreased or increased by just changing the autonomy. So I have increased it. If I increase the autonomy to 3 days, the suggested PV power decreased to from 18 to 15,000 watt nominal. 15,000 watt nominal almost. So for that I am going to just first decrease the requested autonomy to 1 day, which I need, and then select another battery to decrease number of modules further. And this is the maximum AH value in this range, so I need only 4 modules here for 51 volt battery. So this is our battery. Now we go to PV array design. For PV array design, we have suggested PV power of 18,000 watt almost. So you can design using that value, or you can give any other value here for which you are going to design PV modules. And you can choose any PV modules here, from here this list. There are two type of technologies here: SiPoly or SiMono. I'm going to choose a SiPoly module of let's say 280 watt. So I have choose the PV modules For that PV modules, I'm going to resize. So you can see after resizing, I have the number of modules and the area which will be needed for to develop the required power. So our required power which will be developed is 22.5 watt nominal, and the number of modules 90. So change let's change the value here. Let's say 15,000 watt. So resize, and you can see the number of modules has been decreased and the area also decreased, which is 120 meter square, and the nominal power also decreased to 18.5. So I have decreased the value from suggested power for a reason I will discuss in the simulation part. So I am going to decrease value so that I can decrease the nominal power, and I have a 16 kilowatt. For the given is 17 point almost 18 kilowatt. So I have the lowest power. Now we have the battery, but we haven't choose a controller, so let's choose a controller. I'm going to choose an MPPT converter. This will MPPT converter adjust its value according to the PV system which we have designed. So select OK. Now save it. Now I'm going to go to detailed losses. So here we can choose if we have any value of a detailed loss, you can choose it here, or you can just leave it like it, let it be. So for example, I'm going to change it daily soiling loss to 4%, or we can also use a default value of 3%. It's on you. If you have a specific value, you can change it here, or you just go to simulation in the next tab. Okay, save it, and now I'm going to run the simulation. We have defined orientation, user need, system. We are ready for simulation. So this is our simulation. Go to report. So the report is generated in it here. So this is our report. This is in our energy need per day, or hourly distribution of our air conditioner usage. This page all defined our user need. If I have only select one air conditioner, so here we need only 14,000 watt hour per day. So this is our hourly distribution, 6 to 18 hours, 17 hours. Now this is the important graphs and tables which were generated by the PV systems. So these are the kilowatt hour per year available energy and used energy. So we have almost you can say 6,000 kilowatt energy which is excess or unused, you can say. So 5,701 11 kilowatt hour per year is a unused energy or excess energy. So this is a table on which the graphs are made, on the basis of which graphs are made. So here energy user, energy need of the user come in the table of E load, and energy supplied to the user come in the section of E user. So an E load should be less than E user. In January, February, we can see an E user is less than E load, and the some energy is missing. This is because we have no load in January and February month. Our air conditioner is off in January and February. So the solar fraction cells is less than 1 in these months, because solar fraction is a ratio of E load and E user. In the month of March, April, May, June, it's 1, or this if it is greater than 1, it will also be shown as 1. Solar fraction is never greater than 1. So this is En used. The En used shows the energy which is excess from the required value, E load value. So this you can see the E load E unused is greater in the month of March, April. In April it is maximum because the solar radiance is maximum in these months. But in the months of January and February or November, December, it is less because the solar irradiation is less in these months. Available is the total energy available from the PV system or PV plates. Now this graph is made on the basis of this table. This is a graphical representation of the table below. The first blue line shows the unused energy, and the second shows the collection losses, and these are the maximum in April. And then the system losses and battery charging loss is shows in green color, and then the energy supplied to the user is at the last. So these two graphs and the table below are the important components of our simulations. That's all from the simulation of or and the design of PV system, a standalone PV system. So thank you.